Hello, my name is Isabel, and today I'm presenting on the experiment done by Ben Yaku and Dudawai in 2011. Essentially, the research question that was used in this experiment was: does the brain activity right after an event and help predict whether the event will be remembered later? And this is very impactful because most studies were only focusing on the brain activity during a given situation rather than what happens after that situation, and just in terms of brain activity. And the stimuli used were movie clips, and these range from 4 to 16 seconds. But the reason they were used is because they were most likely to mimic like real life situations, which we can actually resonate with, which means we're most likely remembered compared to being shown like random images or random words. And the brain activity was measured using an MRI machine. And so down below you can see that's an MRI machine. And what this does is tracks bold signals. And bold signals are basically the changes in blood oxygen that reflect the brain activity. Um, the methods that were used was the study, resting, and test phase. So the study phase was where the participants were shown that movie clip, and the resting phase was a blank screen that they were shown right after that movie clip, and then the testing phase were open-ended questions to see if they actually remembered what happened. And the cognitive process that this activity was thought to reflect mostly was offline episodic encoding. And essentially, this is the brain taking in what it just saw and binding it together in the memory. Specifically, the parts of the brain that play a role are the hippocampus and the caudate nucleus, which we'll go into further detail later on. And so now we're going to get into the method that were used within both experiments. I broadly mentioned them earlier, but it was the study phase, and this is the first part of the experiment. Um, and this is where the participants watch the clips while undergoing the fMRI scan. And then you have the testing phase where the participants took a memory test outside the scanner to recall the gist of each movie clip. But specifically in the details, experiment 1 and 3 differed. So in experiment 1, the study phase was an 8-second movie clip, or scrambled clips in the scanner, followed by a blank screen that was there for 4 to 12 seconds. And then the testing phase was only 20 minutes later. And the testing phase again was the open-ended questions. Compared to experiment 3, this was slightly different because the participants watched clips of varying lengths. So they were either 8 seconds, 12 seconds, or 16, compared to the 4 to 12 seconds that took place in experiment 1. And they were also followed by that blank screen, which ranged from 8 to 16 seconds. The testing phase was the same as the first experiment, except the memory test took place a day after instead of 20 minutes later. Um, and so after the testing phase, I mentioned that there was a blank interval, just a blank screen, and these were randomly timed. Um, and the best explanation that I can come up for this was so that our brain doesn't like mentally prepare for the next clip and like just get into like this. It would trigger other parts of the brain instead of just it being like a natural occurrence of like showing the next clip. Um, and so there was control within like any experiment. There was control methods. In the first experiment, you have scrambled clips, which were random visuals with background noise. Um, so these clips had no like meaningful narrative, but they helped show whether post-clip activity was truly related to processing meaningful stories and not just like visual auditory stimulation. And then for experiment 3, you have uneventful clips that were taking place in between these meaningful clips. Um, so in these eclipses, like nothing really happens, but the purpose was to show the absence of narrative or change, and it would and whether it was result in less post-clip brain activity. So that would support like this idea that memory kicks in when there's something like meaningful or impactful in front of us. And then on to the next slide. We have experiment 1, which were the results. Oh, yeah, the results of experiment one. So essentially, our results for experiment one, as you can see, the parts that were highlighted in this, sorry. So the highlighted regions of the brain include the bilateral hippocampus, bilateral caudate nucleus, both posterior cerebellum, and the right optic radiation. So those are pointed to the arrow. These areas were highlighted using the subtraction method, which is a common thing used in MRI scans. It's where you have um, an R blink clip and an F blink clip, um, and essentially you subtract these two clips from each other, and the subtraction just highlights these warm areas, these yellow and orange areas, and it shows which parts of the brain were most active. Um, so the color scale represents, as you can see, it ranges from orange to yellow. The warmer the color is, the stronger the difference between the R blink and the F blink, um, showing like which parts are really active. Um, and then if we shift over to the graphs on the right, we can kind of break them down a little bit. So essentially, you have the right hippocampus and the left hippocampus, and you have the x-axis, which represented the time, and then the y-axis that was the bold signals and the strength of them. Um, yes, and then moving on to the lines. So as you can see, there's the red, blue, and gray. So the red line represents the clips that were remembered, the blue represents the clips that were forgotten, and the gray resembled the scrambled clips that didn't have a narrative. As you can see, the remembered ones are the ones that had like um, a meaningful story compared to like the scrambled images, which had no like narrative or nothing impactful that was shown. And then as you can also see, there's these vertical lines, these two solid ones, and then a dash one. The two, sorry, the first one marks where the clip starts, and then the second solid line represents where the clip ends, and then the dash line shows the average time to where the next clip begins. And essentially, the key result from experiment one was that there's a spike in brain activity right after the clip ends, but only for the clips that were remembered. Um, and then moving on to slide 4, we have the results of experiment 3. So the results for experiment 3, essentially you can see like the same brain regions that were active, the hippocampus and the... So for these graphs, you have the green line, the dark green line, and the purple line. So the green line were 8 seconds, the dark green were 12, and the purple were 16. But each curve tracks how brain activity changed depending on that clip length. So that's the key difference between experiment 1 and 3. Is in experiment 1, all the clips were 8 seconds long, compared to experiment 3, where they varied in the time that they were shown. But a question that arises is, we can see that the brain activity is tied to the end of the clip. So that's when you have these large spikes. So essentially what we can conclude from that is the brain waits until the clip finishes, and then the memory related regions activate. So this is very important because we were only focusing on what happens during rather than after. And this essentially is part of memory encoded. It's not just passive processing or slow visual response. It's the brain actually working after the clip is shown. And the main takeaway from experiment 3 is that memory related events in the hippocampus and caudate consistently begins after the event ends, not just a fixed time. And it just confirms that our brain takes this quiet time, which were the blank screen intervals, to start converting the experiments into a long-term memory. And then essentially for our finding conclusions is we have that the hippocampus and caudate nucleus show a spike in activity after an event ends, and this spike predicts whether we'll actually remember the event later. So memory formation is about just what happens during an experience. It's also about what happens later. And this moment of silence when the brain is locking in is like essentially the loading period. And it's a big shift to what we were currently studying because it's focusing on what happens after rather than what happens in the moments. And yes, that was my presentation. Thank you.